Measure and record. Make a line plot. Use the data marks.
Welcome to the Read Measure Marsh. This is Kit, and he's here to help us make sense of a rather messy morning. Over in the shallows, Wren the heron has a problem. She has gathered an entire bundle of cut reeds, far more than she can track with a single glance. If she measures all of these one by one and simply writes down the lengths, she's going to end up with a disorganized pile of individual numbers. To organize that scatter, we use a specific tool called a line plot. It lets us measure each reed to the nearest whole unit and put those numbers in a neat sequence. To understand a large bundle of things, you have to stop looking at the objects themselves and start translating them into an organized visual picture. Wren starts the translation by laying her very first reed flat against a painted ruler, aligning the end exactly at the 0 mark. Looking at the far end of the ruler, this first reed measures exactly 4 units long. This straight number line is marked with evenly spaced whole numbers, 4, 5, 6, and 7. The rule is precise. Each measurement places exactly one X above its matching number. Since the first reed measured 4 units, we draw a single X above the 4. Wren measures the second and third reeds successively, yielding lengths of 5 units and 6 units. Looking at the graph, we track these next 2 measurements by placing a single X above the 5 and another single X above the 6. We have established our even baseline scale, and we are translating each distinct measurement into exactly one identical visual marker. Curious, but what happens when new measurements are identical to lengths we have already plotted? Wren measures the 4th and 5th reeds and discovers that they both measure exactly 6 units long. This chart shows the stacking mechanic in action. When measurements repeat, the new X marks are stacked directly vertical above the existing X at the number 6. Wren records the final reed as 7 units long. We place this single X above the 7 on the number line. Notice the overall shape. The vertical column at the number 6 is noticeably taller than the rest. Stacking identical measurements in the exact same column transforms raw data into a physical shape, revealing which value occurs most frequently. The measuring is done. We can shift our focus away from the physical reads entirely and direct our full attention to analyzing the completed line plot. Tally every X across the plot, 1 plus 1 plus 3 plus 1, confirming 6 total reads. To find the most common length, simply identify the tallest stack. The horizontal spread shows our exact span. The shortest reed was 4 units and the longest 7. The utility of the line plot is its ability to compress a chaotic pile of numbers into a single readable picture. To keep the data organized, measure each reed, find its length on the number line, and stack one X directly above that number. Her data now neatly sorted and securely stacked in the sand, Wren departs the shallows for the morning. Kit, the golden Sheba, concludes his guidance as well, moving confidently onto the next puzzle hidden in the marsh. Before you go, consider this. If Wren found one more reed measuring exactly 6 units, how many X's would then stack in that column? This translation turns a scattered collection of measurements into a visual pattern, allowing you to compare and understand the whole bundle at once.
Each mark is one measure. Look for clusters. Compare the lengths.